Yeah, don't play with the scissors. It's dangerous. All right, so day 2, properties of graphs. We made our foldable and we have our practice worksheet. You guys ready? All right, so let's talk about domain and range. That is your first flap, I guess, right? On the top left. Domain and range. So domain is talking about the x values of a function, right? And we read the domain and range, or domain from left to right. Okay, and here, just kind of as a note for ourselves, let's write this down, okay? If there's an arrow on the left side, so how should we do this? Maybe an arrow on the left side, okay? Sometimes it is pointing straight to the left. Sometimes it might be pointing down. Sometimes it might be pointing up. But either way, if you have an arrow on the left side, where's that headed?
Left.
Left to where? Where do you go when you go all the way to the left for negative infinity? Okay? So that's the same thing if you have an arrow on the right side. It could be going straight out. It might be pointed down. It might be pointed up. But either way, if you have an arrow on the right side, that means you're headed where? To infinity. Okay. All right, so then what is the range? Which values tell me the range?
Y.
Y values. Good. It's the output, right? The range is talking about the Y values of a function. And we always read the domain from the bottom to the top. Okay? And with the range, it's a little bit more clear cut. If you have an arrow going down, right? Where are you headed?
Down.
To where? Negative infinity. If you have an arrow going up, where are you headed? Infinity. Okay? All right, so let's go to the next one. Your next block says continuous function, one-to-one. All right. Well, how do you know if a graph or if a function is continuous? A graph is continuous when it is a single curve. That means that there are no breaks in the graph. There are no gaps. And there are no holes in the graph. Okay? It doesn't mean you have to have arrows going out forever. They may not have arrows. It just means if you think of that as a road and you're driving on that road, you don't have to stop and try to, jump off a cliff or something. Okay? Right? So it just means that there's no break in your graph. All right, so how do you know if a graph is a function? All right, so you know it's a function if there is only one x value for each y value. All right? And that always confuses me. Like, I always have to think about it. But what we really want you to remember about knowing whether a graph is a function is you need to use the the vertical line test. Do you remember that? Good. From Algebra 1, right? And 1 to 1. How do you know if a graph is 1 to 1? All right. Well, this is the opposite. So there is only one y value for each what? X value. Yeah. So then how do you determine that? Well, it's kind of confusing thinking of it like this. So it's a little bit easier if you use the horizontal line test. Okay? And just so we're clear, all right? I mean, you know, it was a long summer. Vertical lines look like what? Show me with your hand. Yeah. Yeah. Okay, good. What does a horizontal line look like? Yes, like the horizon, right? You're at the beach. You're sitting in my kayak and you see the horizon. It looks like this, okay? Just so there's no confusion. All right. Are we okay with this one? Okay, so let's go to the next one. Let's look at the intercepts. Okay? The x-intercepts. All right, well, that's where the graph crosses the x-axis. That's why it's the x-intercepts, right? Here's the cool part. It has other names, all right? So it could be the x-intercept. It could also be the root, the solution, or solutions, I guess. Does anyone know the other name? I mean, it was a while ago when you guys did this in algebra, right? Or the zero. All right. So it has 4 names, and we may use any one of them. Okay, and it means the same thing. X-intercepts, solutions, roots, and zeros. So the y-intercept is where the graph crosses the which axis?
Y.
Yeah, the y-axis. And please remember, you must write this as an ordered pair. That means we write it as x comma y. And you know what? We don't even have to put x comma y. I guess we could say 0 comma y. Because it should be. It should be 0 comma whatever your y-intercept is, right? Questions? Yes.
I don't know what the VLT and the HLT are.
Yes. Okay, so the vertical line test and the horizontal line test, I didn't go into it too much in your foldable because we're going to look at it right now. Okay? All right, so let's go to our white sheets. That's a day 2 properties of functions. It's our practice. So we're going to look at number 1. It says domain. And you know what? This graph, it must be really old. I don't know if you guys can see where the x-axis is. It's the one right here with the little arrow. But if you can't really see it, just make it darker, okay? And here's the y-axis with the little arrow. Yes? Okay, so this is asking me for the domain. All right, so domain, we need to look at this from the left to the right. Okay, here's my tracker. So where does my graph start? If you look on the left side of this graph, is there an arrow?
Negative.
No, there's no arrow, so that means it's not going to negative infinity. This graph really starts at where?
-3.
-3, right? You have to look at the number on the x-axis. Does that make sense? So this graph starts at Do I get parentheses or a bracket here?
Parentheses.
Parentheses. Good. Thank you, Elise. Thank you, Mary. Parentheses because it's an open circle. All right. Yeah.
Oh,
X, right? Mm-hmm. So, yeah.
is it at -3 because that's where the open circle is? Is that what you're talking about?
Because that's the part on the x-axis that this line
You're
is.
referencing the open circle.
Yes, where the open circle is. Yep. All right. So then now I'm going to keep going. My graph is still there. It still exists. Wait a minute. On the right-hand side, what do I have?
Arrow.
An arrow. So then where is that going? Infinity. Okay. And infinities always get what?
Parentheses.
Parentheses. Okay. All right, so now should we do range since we're on this? Yeah. All right, so let me go to a horizontal line because with the range, you've got to look at this from the bottom to the top. Okay? If I look on the bottom part of this graph, all right, so I guess on the bottom, I do have an arrow. You know, it's really weird with these graphs. I know that this arrow is not shooting straight down, right? But I want you to think about something. You do have an arrow going down. If we took this little part of the graph and we zoomed out, yeah? Okay. So imagine that we took this little piece and we zoomed out. Then it would be right? Zoom it out more, it would keep going down. Zoom it out more, and it would keep going down. Does that make sense? This graph? This arrow that you have right here, if you were to zoom out this graph and look at it from like a million, right? Yeah, you would have good vision. You would see that this line would end up going straight down. Does that make sense? Kind of weird, right? But if you have an arrow on the bottom part of your graph, it's eventually going to go straight down. Yeah?
This graph, maybe the line always just -2, but all those x's they take.
You think that's what they...
Yeah,
Okay, sorry. All right, well then, it's easier. All right, well then, it's easier than I thought. Okay, then let's call it that. Let's do that. All right, well then, you know what? For this one, since my range is not going straight down, let's keep it simple then. This is going to stay right here at what?
-2.
At -2. All right, so we'll say -2. Sorry, I try to make it more complicated. Thank you, Mrs. R. All right, so we're going to keep it at -2 because you know what? This doesn't expand yet. It's just going to go straight, okay? Here's the thing, though. How do I know if it's an open or closed?
Because of the arrow.
Yeah, this is a solid line, so it's closed. Go to lunch and we'll come back. All right, so let's go back to this problem. And you know what? I thought about it during lunch, and now that I finally have food in me, I think my brain can work a little bit better. So I'm sorry. Sorry for all that earlier. So let's go back to this problem. We'll talk about the range. The reason why the range is at -2. It's because this arrow tells me that it's just going to go straight, right? Like I said before, the range is going to be clearly down or up. Sorry about that. Okay, so it's staying right at -2, right? And then we were talking about, well, is this an open circle or a closed circle? If you look, this is actually a solid line, right? right on -2, so that means that it is included. So this is equivalent to a closed circle. Okay, does that make sense? All right. So then this would get a bracket. All right. So now, let's see, from the bottom, so from -2, this graph, when we move up, up, the graph is still there. When I get here, that's when my graph levels off, right? What y number is this at?
2.
2. So +2. So then it goes up to +2. And this is a little bit weird because you have an open circle, but you also have this line, right? Whenever you have an open and a closed type of situation, the closed always wins. All right? So this would be a bracket for the range. Does that make sense? All right. Yes? Why is there a bracket for the -2? Because there's a line here. Okay? All right, so now, is this a function? All right. So remember how for the function we said we use a vertical line test. Is that straight? No? You know what? Sorry. I'm just gonna have to use a crooked line. Okay. We use a vertical line test. So what that is if you take a vertical line and you move it through this graph, does it ever hit the graph more than once? So here, it hits the graph one time, right there, right? Here, hits the graph at only one spot, right there. Yes? If your vertical line hits the graph at only one spot, okay, then it is a function. If it hits it at 2 places, then it's not a function. Okay? All right, so then for this one, is it a function? Yes. Okay. All right, so now, is this one-to-one? All right, so a function, you can use the vertical line test. For one-to-one, you have to use the horizontal line test. So basically the same thing except with a horizontal line. You see this middle part right here? It only hits the horizontal line in one spot, right? But when you get down to this, at -2, this space, well, that one doesn't work because this graph is hitting this horizontal line right here, here, and all of these places. Does that make sense? So, yep, and same thing with the +2. Good. So then is this one-to-one? No. Does that make sense, guys? Okay. All right, so now the x-intercept. Basically, I'm going to go and look at my x-axis. Where does this graph touch or cross through the x-axis?
0.
Yeah. Right at the origin here, right? At 0, 0. Okay. Does that make sense? Okay. Should we try the next one too? Do you guys want to try it? Start it. All right? Start it and we'll go over it together.
That's right. We could have, but
Okay,
we do
so
have
let's
minimum
look at
to
this guy
maximum.
together.
Minus 2 to
Domain.
Okay.
So the domain for this means I have to look at it from the left to the right. Okay, so from the left. You know what? I don't have an arrow on the left. So it's not coming from -infinity. It's actually starting at, let's see, -1, -2, -3, -4, right? So domain starts at -4 bracket because it was a closed circle there. And then when I keep going over to the right, look at that. I have an arrow on the right side. So where's that going?
Infinity.
To infinity. And of course, infinity gets parentheses, right? Okay, so let's talk about the range. Okay, so the range, we're looking at it from the bottom to the top, right? And the bottom is negative infinity. Do you guys see any arrows going down? No, so you don't have negative infinity. So we're working our way up, 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 and my graph starts right there. Okay. So since it's here, that means what? -1, -2. Starting at -2. And there, it's not an open circle, so it's closed. Bracket. -2 all the way up. And you see how they overlap? That's okay, right? Up, up. This left side, this little end, that one ends. But look on the right, it's still the same graph, and that one's going on forever and ever and ever, right? So where's that one going?
Infinity.
To infinity. So then that would be your range. Does that make sense? One piece of that graph can stop, but if another piece keeps on going, you have to go with the one that keeps going, okay? It's still the same graph. All right. So now, what are we going to do? Function. Is this a function? Yes? Perfect. If I run a vertical line through this graph, does it ever hit the graph twice? No. So, you're right. It's a function. Good. How about one-to-one? No, it's not. And we showed that earlier, right? Right there. It hits, this horizontal line hits the graph in 2 places, so it is not one-to-one. So the next one is asking us for a y-intercept. So that means, does it say x-intercept? Okay, well then, all right, let's go to x-intercept. All right, so where does this graph cross through the x-intercept? Ooh, right here and right here. We have 2. You can have 2. You can have 3, right? So what are these points? There's one at the origin, so at 0, 0. And what is the other one? Good, -2, 0. Great. All right, questions about that? Okay, let's try some more. So number 3, what is my domain here? Starting from the left. Oh, look at that. I have an arrow on the left. Where's that going? Negative infinity. Eventually this will kind of straighten out. Okay, the further out you go. That's why it's going over to negative infinity. Alright, so negative infinity. All the way to, oh, what else do you have on the right side?
Negative infinity.
Careful, if you're talking about the domain, if you have an arrow on the right side, where's that going? To infinity. You gotta think about the x numbers, right? Okay, so for this one, a U-shaped graph, a parabola, right? The domain is all real numbers, okay? Now, what about the range? Oh, look at that. What do we have? Arrows going where? Down. Down to where? Negative infinity. So this graph is coming up from negative infinity, right? And going up. Where's the x-axis? The x-axis is here. Okay, so then we have to go up 1, 2, right? And that's where the graph ends. So it goes from negative infinity to 2, bracket or parentheses?
Bracket.
Bracket. Good. If you do not see an open circle, it's a closed circle. Okay? Now, since I already have a horizontal line up, is this 1 to 1? No? No. No. Because it hits the graph, the horizontal line hits the graph in 2 points. This is no. Is this a function? What do you guys think? Yes, good. Does your paper say x-intercept or y-intercept? So there? Okay. So what is the x-intercept? Is that weird here? Might be a little bit weird. Those are like, they're not very pretty, is it? Can we change it to y? Yeah. I mean, we don't want to just guess. Can we change that to y? Okay. So then where is the y-intercept?
2, 3.
Looks like it's going to be, where is the y-axis? Right here?
Yeah.
Okay, so it looks like it's going to be there, right? All right, so if the y-intercept is right there, that is at what? 1,
Negative.
2, 3, 4, 5, 6, 7. Negative 7. All right. 0, comma, negative 7. Thank you. How are you guys doing with this? Is it just yeah? We'll keep practicing. Let's do number 4. All right, so let's talk about the domain here. So we have an arrow on the left-hand side. Where's that going?
Up.
Which infinity? Good. We're talking about the domain. So an arrow on the left means it's going towards negative infinity. Right? Negative infinity. And then, oh, look at that. The graph stops right here before it jumps over, right? So you have to tell us it stops at what? What x number?
Negative 2.
Good. Negative 2. Open. So is it parentheses or bracket? Parentheses. Oh, and then it jumps. So that means I need to put a little u, right? And then it jumps over to where? What x number does it start back up at?
Negative 2.
Positive 2, right? What is this x number right here? A positive 2, right? So positive 2 with a closed circle,
Bracket.
bracket, comma, and where is this going?
Infinity.
To infinity, because you have an arrow on the right side. Okay? Now, what about the range? Do I have an arrow going down? No. So this doesn't go down to negative infinity. So I'm coming up from negative infinity, and my graph starts right there. Okay? What y number is that?
Negative 6.
Negative 6. It's a closed circle, so we need to use
Bracket.
bracket. All right. And then we keep going. Oh, we're we're meeting up with the open circle over here, but does that change our range at all? No, because this overlaps with that, so it's still the same graph. You're good. So keep going, and look, you have an arrow going up. Where are they going? To infinity. Does that make sense? Like, this is a wacky graph. Yeah? Okay. So is this a function? Let me see. I have to do the vertical line test. Okay, let me see. Does this hit the graph in, oh, only one spot?
Mm-mm.
No. So is this a function? No. Is this one-to-one?
Mm-hmm.
No. This one actually hits the graph in 4 different spots at one point. So, no. Right? What about the y-intercept? Is there a y-intercept? No. Right?
Mm-mm.
Yeah. The graph never touches or crosses through the y-axis. So, let's write that. Let's write none. Okay? All right, so how are you doing? Okay? All right, well, let's finish our foldable. And we'll get more practice on this stuff, okay? All right, so let's go over to the right side, and we'll talk about maximums and minimums. Okay, so the maximum point is your highest point. Okay? The absolute highest point of your graph is the maximum. And you know what? There are actually 2 we can kind of talk about. The absolute highest is like, this is the highest point of your whole entire graph. Okay? There's another one called local. So you could have a local maximum. All right? And those are just like high parts, pieces. High parts of your graph. Okay? All right, so then your minimum point is going to be your lowest point, right? And the minimum also has an absolute and a local. Okay? And I'll show you the difference between the 2. Right? A parabola, just like the one that we saw. Does this have a maximum, like the highest point? We're talking about like mountains, you know, where the graph changes direction again. Like, this would be a maximum, right? So then this has a minimum. Does that make sense? Okay, so like down in the valley versus top of the mountain. Okay. Are there any other small or high pieces to this graph, like hills or valleys? No. So this one would be your absolute minimum. Okay? If you have a graph like this, See those 2 points, right? Those are your local maximums. And this would be like the local minimum. Okay? It's a lot of information. I know this day is a little bit too much. All right. So let's look at this next part, the increasing and decreasing intervals. And you know, in the past, I think this is the hardest one to kind of understand. With increasing intervals, it's basically talking about how as your x values increase, your y values increase. Yeah, okay? So basically, if you think about increasing, you're saying that the piece of that graph is going up because it's increasing, okay? So the decreasing interval is basically saying like a piece of your graph, right? As your x values increase, okay? Your x values increasing means you're going from the left to the right, yes? Then your y values are getting smaller, they're decreasing. Basically, it's a very technical term for saying that your graph is just going down, okay? All right. So the constant interval is saying that as your x values increase, right? So we're looking at the graph from the left to the right. Your y values stay the same. So basically, if your y values stay the same, then your graph is going how? Yeah, horizontal, just straight, right? Not going up, it's not going down, it's just staying straight. All right, and the end behavior. End behavior is pretty easy. You know, basically the end behavior are basically talking about the arms of the graph. So you have a left arm and you have a right arm. What are the arms doing is what they're saying. As x approaches negative infinity, okay, and you can think of this as your left arm. Oh no, parentheses around. Left arm. All right. As x approaches negative infinity, then where is y approaching? Okay. So it would be written like this. Okay. And how do we remember which arm they're talking about? Well, guys, if you're walking on the x-axis and you want to go towards negative infinity, which way do you have to walk?
Left.
To the left. That's why you know that they're talking about the left arm, okay? Then they're asking you what the y value is doing. You're basically going to say it's either going up to infinity, all right, or it's going down to negative infinity. There's also a, it can get stuck at an asymptote, so it might be straight, okay? But, okay, we'll write that down. So, stuck at an asymptote, but that's just a note for now, okay? This is our, I don't think we have any where it's stuck in an asymptote, right?
Remember the first graph we couldn't figure out? That one is fine.
Yeah, that one has it. All right, so then the right end behavior. It's basically saying as x approaches positive infinity. So now we're talking about the right arm. Okay? Then where is y approaching? So this one looks very similar to the left arm. It will be written like this, as x approaches positive infinity. Again, just think of, well, if I'm on the x-axis and I want to walk towards infinity, which way do I have to go? I have to go to the right. So this is asking about the right arm. Okay? Same thing. If it's going up to infinity. If it's going down, it's going to negative infinity. Or it can be stuck at an asymptote, and then that's just your y value. Okay? Oh, and here we go. 3 choices. Those are your 3. Up, down, or stuck. Okay? All right, any questions so far? Let's try some of these out. I know, guys, hang in there. Okay, so let's go back to our white sheet, our practice sheet. And we're going to use this graph to answer the questions. So 5, 6, and 7 are asking us where this graph is increasing and where it's decreasing and where it's constant. So first of all, look at this graph. Is there any part of this graph where it's going straight? No, right? So interval when f of x is constant, none, right? It's not straight at all. Horizontal, straight. Horizontally straight. Right? And then it's saying interval when f of x is decreasing. Guys, is this graph from the left to the right, is it going down and decreasing at all? No, right? This graph, no, it's, right, not decreasing, so this is none. So the last one says interval when f of x is increasing, right? So if we look at this graph, honestly, the whole entire thing is increasing, right? So the thing about these increasing, decreasing, and constant intervals is that you have to tell us the x numbers from where it's increasing or decreasing. So if I have an arrow going to the left, where am I headed on the x-axis?
Negative infinity.
Yeah, negative infinity. So I'm saying, okay, this arrow on the left means I'm going to negative infinity. And then if I look over here, I have an arrow on the right. Where's that going? To infinity. So from negative infinity to infinity, which is where this graph exists, right? Where is this increasing? The whole way, right? That's what that means, okay? Since we have these arrows going out, like on both sides, if you were reading this graph from the left to the right, it's just increasing the whole way, okay? So then you would say from negative infinity to infinity is increasing, all right? Okay, so the next part asks, what is the maximum? All right, so you know how I was saying the maximum and the minimum, you have to think of it as down in the valley or up on top of the mountain. right? Well, you have to because the infinity and negative infinity, those don't count. That's why it has to be like a mountain. It has to curve around, okay? This straight line, does this ever curve around? Does a straight line ever curve? No. So this really doesn't have a maximum. All right? So then maximum, none. Okay? So how about the minimum? Does this ever curve down? No. So straight line, no maximum, no minimum. Okay? Now, end behaviors. As x approaches negative infinity, remember how we talked about if you're on the x-axis and you want to walk towards negative infinity, you have to walk to the left, right? There is a left arrow, so, okay. Let me look at my left arm. Where's that going? Up, down, or straight? Down. Down to where? Negative infinity. Okay. And the next one says, as x approaches infinity, well, walking on the x-axis towards infinity, that's your right side, your right arm. And what is your right arm doing? Where's that going?
Infinity.
It's going up to infinity. Okay? All right. Can you guys go back to your purple foldable, right? To your increasing and decreasing intervals? Can we make a little note somewhere? We always use parentheses. You never use brackets when you're talking about increasing, decreasing, and constant. Okay. All right, so let's go to this crazy looking graph on the back of your white sheet. Hang in there, we're almost done, okay? All right. So let's look at g of x. Is g of x a function? Is this a function? Let's use the vertical line test. Is this a function?
No.
Okay, so I heard no and I heard yes. Does this graph ever hit this vertical line in two places? Ooh. Right here, huh? See right there? Right? So, no. Not a function. Okay, is this continuous? Yes, good. If this is a road and I'm driving on it, are there any breaks or holes or gaps?
Mm-mm.
No, I can drive on the whole thing. So, all right. It's continuous. Is this one-to-one? No, it's not. Good. Right there, right? Crooked line. There we go. Okay, and now it wants the domain in interval notation. Is that straight?
No.
Okay. So I don't have arrows, so I know I don't have the infinities. Let's see where this graph starts when I come over from the left. What x number does it start at?
-4.
-4. That's a closed circle, bracket or parentheses?
Bracket.
Bracket. So -4 all the way to what x number?
10.
To 10. Okay.
Bracket.
Bracket. Okay. Now the range. So I need to start from the bottom to the top. You know what? I don't have any arrows, so I know I don't have a negative infinity. Where does this graph start? What y number?
-10.
Good. Bracket -10. And then it goes up. I know the right part ends there, but the left part keeps on going, right? And keep going. Where does the graph stop?
-4.
10, right? You gotta think of the y number. You say -4, you're saying it ends here. Right? The graph stops at 10. Y number 10. Bracket. Okay? Alright, so, you know what? We'll come back to the increasing, decreasing, and constant. Let's go to the x-intercepts. Let's do something a little bit easier first. X-intercept. Where does this graph cross through the x-axis? Here and here. I'm just going to have to eyeball this one. So we could say about what? A little shy of 1. Can we say like 0.8? 0.8, comma 0. What would the other one be, approximately? 9 point what? 2? 9.2? Okay, so what is the y-intercept? Where does this graph cross through or touch the y-axis?
4.
Good, so how do we write that? Order pair, 0, comma 4. Okay, what is the maximum? Is there a top of the hill? No, there's no maximum. What is the minimum? What is the lowest point? I guess the lowest, was it down the valley? -10. Give me the actual point.
About -10.
Yeah.
5, -10. Okay. So remember, it's a maximum point and a minimum point. Down the bottom, it says this graph does not have, please write in end behaviors. Okay, and that's okay. Not every single graph that you encounter is going to have an end behavior. You only have end behaviors when you have arrows for arms. Okay, not the little nubs. All right, so let's talk about increasing and decreasing. Okay, so increasing and decreasing, over the years of teaching Algebra 2, this is the easiest way I've come up with to teach this, Ms. R. This thing is crazy, that's why. So, what you want to do when you get a graph, right, is you want to see if there are any points where the graph changes direction, okay? So, if I look at this graph, well, I have a point here where it actually starts, right? So I'm going to say, all right, here's where my graph starts, right there. I'm going to draw a little dotted line, a vertical dotted line, okay? And that starts right there. The x number is -4. Yes? You guys see what I just did? You see where I got the -4? Okay, let me say it again. This graph starts here at this point, right? Okay, so I'm going to draw a dashed line right where this graph starts. And what is the x number that this graph, that this line crosses through? -4. Okay, so I'm going to put my -4 right there. All right. And then I see my graph is going, and then it changes direction right there. Yeah? So I'm going to draw another dotted line where it changes direction. Okay? And what x number does this dotted line go through?
1.
+1. Okay, so up here I'm going to write +1. All right? Anywhere that the graph changes direction. So from here, going, it changes direction right there. So I'm going to draw another dotted line. And what x number does this dotted line go through?
5.
+5. And you know, this side is not an arrow, so I have to actually draw a dotted line right where the graph actually ends. Okay? If it was an arrow, I would say infinity, because all the way to the right is infinity. But this stops at 10. Do you agree?
Mm-hmm.
Okay. So now, what do I do with this? Well, guys, you basically did all the work. These are your intervals. You just have to decide whether it's increasing, decreasing, or constant. So if you look at your graph from -4 to 1, what is your graph doing?
Going down.
It's decreasing. Good. So here is decreasing. Do you see what I'm doing? Yeah? Okay. So then, now look at what this interval is doing from 1 to 5. Remember, always from left to right. What is this doing?
Down.
That one's decreasing as well. Okay. Yeah? And then look at it from 5 to 10. What is this doing?
Up.
It's increasing. Okay, so for that one, I'm going to put an I. Yeah? All right, so now I can go back to my intervals and I can fill in this missing information. So, do I have any constants? Are there any C's?
Mm-mm.
No, so I'm going to put none. Because you can't just leave it blank. You have to write none, please. Where it's increasing, from what number to what number is it increasing?
5 to 10.
Okay, remember, and we always use parentheses. So 5 to 10 is increasing. Right? And then where is this decreasing? You know, I know that I have the 2 intervals, but if your decreasing is side by side, can we just skip it and go, yeah, can we do that? Since they're right next to each other? -4 to 5. Does that make sense?
Mm-hmm.
All right. Okay, so we're done with the practice sheet. If you look inside your foldable, you have this wacky looking graph.
There's 2.
I would like you guys, I know there are 2 wacky looking graphs. I want you guys to pick one that you would like to do right now and that you want me to put the answers up to. The first one or the second one?
Second one.
Second one? Yeah. Let's do the second one then, because that one actually has arrows. For the second one, I want you guys to try all of those, but can we do the increasing, decreasing, and constant right now? Okay, because I want you to see one that has arrows. So, for this one, I have an arrow over here on the left. So, think about it, right? We're talking about x numbers. If I have an arrow going to the left on my x-axis, where am I going? Huh?
Negative infinity.
Yep, negative infinity. So from negative infinity all the way to, where does this graph change direction? Yeah, right there. So I'm going to draw a little dotted line. I'm going to say, well, this dotted line crosses through at 4. And then on the right side, look, I have an arrow going to the right. Where's that going? Positive infinity.
And there's no constant, right?
There's no constant because there's no point on this graph where it's going straight horizontally. So constant interval, I can write none. Now let's think about what this is doing from negative infinity to 4, from the left to right. What is this graph doing? It's decreasing. Good. So then what is this graph doing from 4 to infinity? It's increasing. Okay. So increasing interval is from what number to what number? Yeah, 4 to infinity. And remember, the intervals always get parentheses. And decreasing interval would be from what to what?
Negative infinity to 4.
Thank you. All right, I want you guys to fill out the rest of that, please. You can work together. You can work by yourself. You can compare. All right? Thank you. So, guys, I'll put up my answers up here. Please check. Make sure I do this right. Make sure we have the same thing. Okay? And if you have any questions about it, then please ask. All right? Okay, so here are my answers. Do we have the same thing?
Yep.
Okay, good. And if we don't have the same thing, then we'll walk around. Maybe you guys can show us. What is your homework? B. Homework B. Do you have any quizzes or